is acting upon it. So we have completed here.
Yes, sir.
Okay. So
Yes.
let's start. Right. The relation between force and potential. Relation between is F is equal to minus dv by dx. So there is a relationship between net external force acting upon a particle, okay, and the potential energy. So this is the relation F is equal to minus dv by dx. But for free particle, what is your F? F is equal to 0.
F0.
No external force means F is equal to 0. Okay. So if F is equal to 0, so this implies dv by dx is equal to 0. If dv by dx is equal to 0, so v is equal to constant. You know, if derivative of a constant is equal to 0, so dv by dx is equal to 0 means v is equal to constant. Okay. So this v is equal to constant, or we can say v is equal to 0. So constant means we can take any numeric value which can be chosen to be 0. Okay. So this is the condition for free particle. Remember, this is the condition. If short question asked, what is the condition for free particle? This is the condition for free particle. Okay, v is equal to 0. So now in application part we have to apply the time independent Schrodinger equation. Okay, so write time independent Schrodinger equation for free particle. Time independent Schrodinger equation for free particle is Soumya.
Yes, sir.
What is time independent Schrodinger equation? Hmm.
Sir, del square psi by del x square plus
Huh?
2m by
2m by h cross square.
s cross square all into e minus b all into psi equal to 0.
Okay, very good. So the time independent Schrodinger equation for free particle is particle. We got what is the value of v? V is
Equal
equal
to
to 0.
0.
Okay. So this implies d square psi by ds square plus 2m by h cross square e psi is equal to 0. Because v is equal to 0 for free particle, since v is equal to 0, we have taken. Okay. If question asks write down the time independent Schrodinger equation for free particle, so directly you can write this d square psi by ds square plus 2m by h cross square e psi is equal to 0. So 2 is constant, m is constant, h cross is constant. So let us substitute a new constant as k square psi is equal to 0. Okay. So this is your equation number 1, where I have taken k square is equal to 2m by h cross square into e. K square is equal to 2m by h cross square into e. Okay. So the equation 1 is your type independent Schrodinger equation for the free particle, and it is a second order differential equation. Already you have read at module 1 in case of simple harmonic oscillation, damped harmonic oscillation. Okay. Uh, Basically, what is the solution of a second order? This is the second order differential equation. Okay. The variable, so this implies the solution the solution of equation 1 is, what is the solution? We can write psi x is equal to, okay, psi x is equal to a e to the power I kx plus b e to the power minus I kx. This is equation number 2. You give k square is equal to this as equation number 2, and this is a e to the power I kx plus b e to the power minus I kx. Okay, so we can write the solution in terms of exponential function. This is known as exponential function. Okay, where a and b are unknown constant. So this is the general solution, where note down a and b are arbitrary constant, arbitrary constants to be determined, these are the unknown arbitrary constants to be determined by using the boundary condition. Okay, but for free particle it is not required. Okay, sarla lekha sarla pragya.
Yes, sir.
Okay, so now look here, the solution gives you two parts. This is your first part, this is second part. Okay, the first part is known as a plane wave moving along positive x-axis. Okay, so write the part you can write here a e to the power I kx is known as a plane wave moving along positive x-axis. A e to the power I kx, it represents you a plane wave moving along positive x-axis. Okay, and the second term b e to the power minus I kx represents you the plane wave moving along negative x-axis. Okay, that means this is positive x-axis, the wave is moving along positive x-axis, and this is another wave moving along negative x-axis. So this is the pictorial representation of the free particle. Okay, understood?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Next, write the from equation 2, energy eigenvalue. The energy eigenvalue is, what is the equation 2? K square is equal to 2m by h, k square by 2m. So this is known as energy eigenvalue. This is equation number 4. Of k, the energy can take any finite value. Note down, since there is no restriction on the value of k here the wave propagation vector, the energy can take any finite value.
Since there is no restriction
On the value of k, the energy can take any finite value.
Sir, infinite value.
Any finite value, not infinite. There is no restriction on the value of k is constant, so the energy can take any finite value. So, the energy spectrum of the free particle is continuous. So, the energy spectrum of the free particle is continuous.
So the energy spectrum.
So, the energy spectrum of the free particle is continuous.
Spectrum.
Okay. Energy spectrum of the free particle is continuous. We can get the energy spectrum which is a continuous manner, not a discontinuous, in a continuous. Okay? Salah?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Continuous, lekha. And the energy eigenvalue is degenerate. Underline. The energy eigenvalue is degenerate. The energy eigenvalue is degenerate. So these are the some discussion you have to write. Okay? विकास
Yes, sir.
विकास रीड करो क्या लिखे हैं लास्ट में.
Sir, last में sir.
नहीं लास्ट में नहीं, जो डिस्कशन एनर्जी इक्वेशन 4 के बाद, इक्वेशन 4 के बाद क्या लिखे एक बार रीड करो.
Yes. Sir, since there is no restriction on the value of k, the energy can take any finite value. So the energy spectrum of the free particle continuous and the energy eigenvalue degenerate.
Energy eigenvalue is degenerate. Look here.
Yes, sir.
Everybody, this is equation number 4. So E depends upon K. So there is no restriction. K is a constant. K, there is no restriction on the value of K. So we can take energy, can take any energy spectrum, can take any energy spectrum of the free particle is continuous. And the Eigen function means A e to the power ikx and B e to the power minus ikx corresponds to same eigenvalue. So both eigenfunctions corresponds to same eigenvalue. So it is known as degenerate. It is known as degenerate. Okay. So this is your free particle. So the second application, which is important. Okay. So right. Particle enclosed in one dimensional potential box of infinite height or it is known as infinitely deep potential well. Infinitely deep potential Abhinandan.
Yes, sir.
So what is the heading written by me? You read.
Particle enclosed in dimensional potential box of infinite height or infinitely deep potential well.
Pragya.
Yes, sir.
कौन लिखा है पढ़ो.
Particle enclosed in one-dimensional potential box of infinite height, or it is known as infinitely deep potential.
Potential well is there. Okay.
Yes, sir.
Okay. So look here. You do this diagram. Be quick. Okay, diagram complete. सल्ला परिचय. अरे सला ना नहीं.
Yes, sir.
No, sir. Left.
Yes, sir. Yes.
Okay, complete.
Yes, sir.
Yes, sir.
Okay. So look here. Our heading is particle enclosed in an one-dimensional potential box of infinite height. That means what is the meaning of this line? One particle is kept inside one box. So that box is one dimension and the height is infinite. So let us construct a potential box. This is a potential box, one dimensional potential box. Height is infinite, and inside the box, inside the potential box, one particle is present whose mass is m, energy is E. Okay. So when you make the potential box having infinite height, what is the width of the box? So like the box, we are using the box. The width of the box will be A. I have taken small a with the width of the box. So this is the origin, x is equal to 0, x is equal to A. That means small a with the width of the box. But important thing is, inside the potential box, the potential energy is equal to 0. Okay. So let one frog is present inside this box. So always frog is moving from one point to another point. So potential energy. So potential energy is. So this is the box having a perfectly rigid and elastic wall. So these are the rigid and elastic wall. Outside of the box, the potential energy is equal to infinite. This is infinite. This is also infinite. Understood? So this is the diagram, pictorial representation of what? One particle is kept inside one-dimensional potential box, or we can say infinitely deep potential well. Potential well. Well means kua. Like in our village area, the previously people are used the water from well. Okay. So nowadays well or water connection pipe is there, but very ancient times the village people use that water taken from the well. Okay. So this is underground portion which is known as well. Okay, understood?
Yes, sir.
So this is so right. Consider the particle of mass m and energy E moving 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 inside one dimensional box from x is equal to 0 to x is equal to a along x axis. We have to make the box along x axis. Okay. Next, right? The particle is free to move between the walls. The particle is free. The particle is free. शीघ्र लेख सारी बाजी टा. The particle is free to move between the walls. So these are the walls, between the walls. Okay?
Yes, sir.
The particle is free to move between the walls. Okay. So now, right, the box is assumed. The box is assumed to have perfectly rigid and elastic at x is equal to 0 and x is equal to a. That means these are the wall, or we can say the box is assumed to have perfectly rigid, very solid material and elastic at x is equal to 0 and x is equal to a. Okay, a with the width of the box. We have to make the box having width a. Okay, so here we have to apply one condition. What is the condition? So condition is, mathematically we have to write the potential, means potential energy is infinity at which point? For x less than 0 and x greater than a. Okay. Similarly, the potential is equal to 0 for 0 less than x less than a. So you have to mention these two things. The potential energy, the potential is equal to infinity outside. This is less than, this is greater than. That means outside the wall, the potential is equal to infinity. But inside the well, inside the box, what is your potential? Potential is equal to 0. For 0 less than x less than a. So this is known as region 1, this is known as region 2. Okay? Understood?
Yes, sir.
For x less than equal to 0, sir.
Vx is equal to 0 for 0 less than x less than a. Okay? इंफिनिटी होगा कहाँ पे? देखो ना, ये बाहर में ना वाल का बाहर में इंफिनिटी हो जाएगा. उसका कंडीशन क्या हो जाएगा? ये x लेस देन 0, यहाँ पे तो 0 है. ये सब बाकी चीज क्या होगा? x लेस देन 0 होगा. ये क्या होगा? x ग्रेटर देन a होगा. वही चीज हम लिखे हैं. ओके, समझ में आया?
Yes, sir.
Okay. Next. After writing the condition, we have to by using the time independent Schrodinger equation, we have to solve it. Okay. So next step, right? Time independent Schrodinger equation. Time independent Schrodinger equation is time independent Schrodinger equation for region 2. For region 2, why I have written region 2, I shall tell you. You can note down, this is region 1. This is you can note down region 1, and this is your region 2. Why I have not taken region 1? Because look here, if you write the time independent Schrodinger equation, time independent Schrodinger equation is d square psi by ds square plus 2m by h cross square E minus B. So if I shall consider region 1, region 1 में B का वैल्यू कितना है? Infinity. So E minus infinity we cannot solve. So the region 1 cannot be acceptable. Understood?
Yes, sir.
Yes, sir.
Yes, sir.
Understood? So we can take region 2 only. So in region 2, what is the value of V? V is equal to region 2 में V का वैल्यू कितना है?
0.
0. So E is there only is equal to 0. So this implies d square psi by ds square plus k square psi is equal to 0. Again, this is equation number 1. Okay, where k square is equal to 2m by h cross square into E. So like your free particle, we got the equation. So what will be the solution? Who can say? What is the solution of equation 1? Mona Lisa? Mona Lisa? Hassan Raja? Who can give the answer? What is the solution of equation 1?
Psi x is equal to
Yes.
Yes, sir.
a e
Ah,
to
tell
the
me.
power ikx plus b e to the power minus ikx.
Very good. Just today we have done for free particle. If you compare, there is no difference between free particle, the expression for free particle given by equation 1 and 2, and here is also equation 1 and 2. So both are remain same. Am I right? So it is a second order differential equation. Equation 2 is a second order differential equation. The solution will be psi x is equal to a. Okay, since I have used e to the power ikx, now I want to take in terms of trigonometric function. Okay, so psi x is equal to a sin kx plus b cos kx. You can also take in terms of exponential, no problem. E to the power ikx plus b e to the power minus ikx. So to write the equation in a more convenient way, I have used in terms of trigonometric function. Okay? So that e to the power ikx, e to the power minus ikx can be expressed as a combination of sin kx plus cos kx. So where this is equation number 2, equation number 3. where right A and B are two constants which are to be determined from the boundary condition. Okay, look where A and B are two constants A and B are two constants. Okay, look here. A and B are two constants to be determined to be determined from the boundary conditions we have not done in case of free particle but the value of unknown constants using the boundary conditions. बुझला?
Yes,
Okay.
Yes.
Yes, sir.
A and B are two constants to be determined from the boundary conditions. Okay, so what are the boundary conditions? Now we have to apply the boundary conditions. लिखो. Boundary conditions. Number one boundary condition is at x is equal to 0. All of you look your diagram. When x is equal to 0, there is no existence of the particle. All of you look your diagram. At x is equal to 0. Soumya, what is x is equal to 0? It is nothing. The perfectly rigid wall.
Yes.
See the wall
Yes, sir.
which is elastic. Have you ever seen the particle stage over the wall? केबे हेले गोटे फ्रॉग ए वॉल ऊपर रही परिबो की?
no, sir.
No, sir.
Since it is elastic, perfectly rigid, the particle cannot stay at x is equal to 0. So if x is equal to 0, that means the wave function vanishes. A wave function means what? The existence of the particle. The wave function vanishes. Similarly, if you take at x is equal to a, the particle does not exist. That means psi x also 0. Okay, so write at x is equal to 0, psi x is equal to 0. So putting this, right, putting this in equation 3, कौन हबो कुह निजे टे कुह रे पिले. Putting this in equation 3 केता हबो कौन लिखिबी?
A sin kx plus b cos kx is equal to 0.
That means psi x is equal to 0. First I have to write 0 is equal to a sin kx. X is equal to 0 means sin 0 s plus b cos 0. All of you know sin 0 is equal to 0, cos 0 is equal to 1. So this implies b is equal to 0. So we got the unknown constant b is equal to 0. Okay. So if b is equal to 0, putting this in equation 3, putting b is equal to 0 in equation 3, we have psi x is equal to a sin kx. This is equation number 4. Okay. So if b is equal to 0, psi x is equal to a sin kx. Hello, nahi?
Yes, sir.
Now we have to apply the second boundary condition. At x is equal to a, what is your psi x? Who can say? Already I koi at x is equal to a,
Zero.
what is your psi x?
0.
Very good. Psi x is equal to 0 means in that is the wall of the well or the wall of the potential box where the particle does not exist. If the particle does not exist, how can we find the wave function? The wave function becomes 0. Okay? Now, this is your second boundary condition. Okay? So, applying this second boundary condition, on which equation we have to apply? On which equation we have to apply the second boundary condition? Who can say?
Equation 3.
Tell me. No, equation 3. Now equation 3 reduces to equation number 4. So we have to apply in equation number 4. Okay?
Yes, sir.
Right. At x is equal to a, psi x is equal to 0, putting this in equation 4. If you put the second boundary condition in equation 4, what will be the result? Who can say?
Psi of A is equal to A sin
Equation 4 is equal to psi x. I have to write, instead of x, I have to write a. But the second boundary condition said that psi x is equal to 0.
0 is equal to A sin KA.
Now, so this implies a sin ka is equal to 0. Lekla?
Yes, sir.
Yes, sir.
Good time. So a sin ka is equal to 0 since whether a is equal to 0, a is not equal to 0. We are going to determine it. So a is not equal to 0. So which will be 0?
Sin KA will be 0.
If sin ka is equal to 0, what is the value of ka?
0.
0. Yes. The general solution will be plus n pi. So ka is equal to plus minus n pi. So this implies k is equal to plus minus n pi by a. This is which equation number? 5. We got k is equal to plus minus n pi by a. But our objective is we have to determine what is the value of a. Look where n is equal to 1, 2, 3, etc. except 0. Who can say? I have taken sin theta is equal to 0, theta is equal to plus minus n pi. Here n is nothing, here n is 0, 1, 2, 3, etc. But here 0 cannot be taken. Why? If you take n is equal to 0, if you take n is equal to 0, k is equal to 0. So k is equal to 0 means the wave function is equal to 0. Why? We have psi x is equal to a sin kx. So now k is equal to 0. So sin 0 is equal to 0. Psi x is equal to 0. So psi x is equal to 0 means the particle does not exist. Okay? बुझेला?
Yes, sir.
आज n is equal to 1, 2, 3 except 0 देखो as it makes k is equal to 0, ultimately psi x is equal to 0. शीघ्र लिखो आज कौन लिखिल?
It makes k is equals to 0.
Hello?
As it makes k equal to 0, ultimately psi x equal to 0.
Which implies that non-existence of the particle inside the box.
Which implies that
Non-existence of the particle. Non-existence of the particle inside the deep potential box. If we can take n is equal to 0, then there will be not existence of the particle inside the box. Okay? Next. Now, after some time, I shall determine what is the value of A. We got B is equal to 0. Still, we have not determined what is the value of capital A. Okay? So now, right. Just wait. Before that, write energy eigenvalue. What is the energy eigenvalue of the particle? Okay. From equation 2, what is your equation number 2?
Del square psi
Hmm.
x square plus k
Sir,
square
k square is equal to
0.
2m by h square e.
What is your equation number 5?
K equal to plus or minus n pi.
By A.
N pi by A.
by
n
No,
pi
n pi
by
by
a.
So write 5. You take square. K square is equal to n square pi square by s square. Okay. Now, from equation 2, we know k square is equal to 2m by h cross square into e. Understood? From equation 2, from equation 2, what is the value of k square? 2m by h cross
by
square
H
into e.
square.
So here the right hand side will remain same. From this expression, E is equal to n square pi square h cross square 2m by a square. This is which equation number 6. This equation 6 represents the energy eigenvalue. This is known as energy eigenvalue. So what is the formula for energy eigenvalue, Ruturaj?
E is equal to n square pi square by h cross square, n square pi square into h cross square by 2m a square.
2m a square. Okay. Since it depends upon n, we can write n. En is equal to n square pi square h cross square by 2m a square. or I can say this En is directly proportional to n square. All are constant. Pi, h cross, mass, width, all are constant. So it is directly depends upon n square. Next, write different energy eigenvalue. Different energy eigenvalue. Since energy eigenvalue depends upon n is equal to 1, 2, 3, etc. So we have different energy eigenvalues. For n is equal to 1, what is your E1? You put equation 6. For n is equal to 1,
by 2m square.
huh?
Pi square h cross square by 2m square.
Huh. Pi square, that means h cross square, pi square by 2m into s square. So this E1 is known as 0 point energy.
চার্জের হলে বসে দেবো
or ground state energy. So write the definition. The energy possessed by the particle at ground state the energy possessed by the particle at the ground state is called 0 point energy. कौन लिख रे?
The energy possessed by the particle at ground state is called 0 point energy.
Okay, এটা definition পচারে short question. Okay, your classical physics said that E1 means 0 point energy is equal to 0. But quantum physics said that it is not equal to 0. E1 is not equal to 4. Whether this expression is equal to 0? No. H cross square pi square by 2m a square. So it is not equal to 0. So there is a contradiction between classical physics and quantum physics. We have taken E1 is equal to this, equation number 7. Now similarly find n is equal to 2. What will happen?
Therefore, pi square h square by 2m a square.
Very good. एक मिनट. For n is equal to 2, E2 is equal to 4 pi square h cross square by 2m into a square. So what is this? This is nothing. 4 into E1. Are 4 times the 0 point energy. Similarly, put n is equal to 3. It will be how much? N square. 9 pi square h cross square by twice m a square. This is equal to 9 into E1. Are understood?
Yes, sir.
Yes.
Okay.
Yes, sir.
Now, in general, you tell me what will be En? En is equal to n square into E1. Suppose on your question, the 0 point energy is given. Okay? Find the energy eigenvalue at second excited state. What will be the answer?
4 into E1.
4E1, sir.
4E1.
No, no. If I shall show you, look here. If this
9E1,
is
9E1.
9E1.
yes, 9E1, very good. If this will be 0 point energy, E1, the next level will be first excited state, that is your E2.
Yes.
So next will be E3. E3 means this is second excited state, E4, third excited state, up to En. En means this is what? N minus 1 excited state. Okay, so 0 point energy, N is equal to 1, N is equal to 2, N is equal to 3, like this. Okay, so but E2 is known as not second excited state, it is first excited state. You have to remember carefully. So E2 is known as first excited state. Similarly, this is second excited state, third excited state, like this. Okay? So whatever question is asking, energy is given, find the energy eigenvalue at second excited state. So second excited state means you have to calculate E3. So E3 is equal to 3 raised square is equal to 9, multiply with E1, whatever the value you can write. Okay, so En is equal to n square into E1. Okay, understood?
Yes, sir.
Yes, sir.
Okay, but there is a contradiction between classical physics and quantum physics. Classical physics said that 0 point energy, this is the 0 point energy, is 0. You can note down, this is 0 point. But quantum physics said that it is not equal to 0. Okay. So next we have to find the energy gap. Energy gap, that is del E. So it is very simple. The separation between two consecutive energy level, right? The separation between two consecutive energy level. The separation between two consecutive energy levels is called energy gap. Okay? The separation between two consecutive energy levels is called energy gap. Okay, so that energy gap del E, two consecutive, E2 minus E1, E3 minus E2, E4 minus E3, like this. So if you find in general, it will be En minus En minus 1. So you know En, you apply the formula n square pi square h cross square by 2ma square minus n minus 1 means n minus 1 whole square pi square h cross square divided by 2ma square. Okay, so if you determine the value is equal to 2n minus 1, so the energy gap is equal to 2n minus 1 into E1. इक्वी स्पेस, दोनों एनर्जी लेवल के बीच में जो स्पेस होता है वो इक्वल नहीं होता है. सो इट इज 2n minus 1 into E1. So next is Eigen function. Okay. So here in Eigen function, we have to determine the value of A. Okay. So right, to find the value of capital A, to find the value of capital A, we have to apply the normalization condition. We have to apply the normalization condition, which is कौन लिख ले पहले?
To find the value of capital A, we have to apply the normalization condition.
So what is the normalization condition? पढ़ा है चिकुआ. What is your normalization condition?
Sir, psi mod square dx equal to 1.
D equal to 1. Integration minus
अच्छी तरह
infinity to
पढ़ना
infinite.
कौन करिया रे मुख खाली गोटे आज हाँ?
Integration minus infinite to infinite.
So Eigen function, you can write psi n x, we have to determine. Here we have to determine determination of constant A. We have to determine the constant A. Already we determined B is equal to 0. Now what is A? To find the value of capital A, we have to apply the normalization condition, which is integration
Psi mod square
psi mod square
dx equal to
Is equal to 1.
equal to 1. But in our case, what is the limiting value? 0 to A. 0 to A. What is psi x? Equation number psi x देखो. Psi x.
a sin k.
A sin
A sin
kx.
kx.
A sin kx. A sin kx whole square dx is equal to 1. You know the integration, everybody. So just I am doing one step. A square 0 to A sin square kx dx is equal to 1. A square is A square taking outside. Sin kx square means sin square kx dx is equal to 1. So after this you leave 1, 2, 3, 4, 5, 6, 7, 8. You leave 8 step. Next class I shall check the integration. And finally the value comes 2 by small a under root. Everybody you leave how many steps I told you? 6 to 7.
8.
Okay. 8. You leave 8 steps and on 9 step I can find the capital A is equal to 2 by A under root. Okay, I shall check whether you have done integration or not. So this A by 2A, what is your expression, equation number? Hello?
7.
8.
8.
7.
8.
8, sir.
7. This is equation number 8. A is equal to 2 by A under root. So this equation 8 is known as normalization constant. This is known as, okay, whatever, this is equation 7. So A is equal to 2 by A under root, which is known as normalization constant, where capital A is unknown constant, small a is known as width of the potential box. Okay, understood? So after writing the time independent Schrodinger equation, we got the solution. The solution consists of two unknown constant a and b. Using the boundary condition, we got b is equal to 0, and using the using another boundary condition, we got a is equal to 2 by a under root by applying the normalization condition. Okay, so capital A is equal to 2 by a under root. So the capital A is known as normalization constant. So what will be your Eigen function? Eigen function of the particle which is kept inside the well. The Eigen function means the solution. The solution means, what is that equation number? The solution means equation number 4. Okay. So write the Eigen function psi x is equal to a sin kx. It is our Eigen function. So now you put a value, a is equal to 2 by a under root sin kx. Okay. So this implies psi x is equal to 2 by a under root sin the value of k is equal to n pi by a into x. Equation number 8. So this equation 8 is known as Eigen function of the particle. Since k ର value କେତେ ନିଆଯାଇଥିଲା? K is equal to n pi by a. Okay. Since Eigen function depends upon n, we can put n. Psi n is equal to this. Okay. Psi n x is equal to 2 by a sin n pi by a into x. Okay, understood? Bujila?
Yes, sir.
Yes, sir.
So, for the offline examination, you have to prepare the very important block question. The question is, solve time independent Schrodinger equation of a particle enclosed in an one-dimensional potential box of infinite height. Find the energy eigenvalue and Eigen function. Okay, so you have to do. So this is one of the important question. Only small portions left, so that we shall complete it. The different Eigen function for different quantum states and the probability of finding the particle. Okay, so time is over. Next class I shall teach you. Okay, so you take the screenshot, you share me.